Hey guys, my guest tonight, Stephen Kane, is going to be talking about exoplanets and other celestial bodies. See you in about 5 minutes. Grab your popcorn and snacks. Find a comfy spot, take a seat or lie down, and let me transport you to a place of fantasy, ghost stories, ancient legends, odd creatures, alien encounters, and other magical topics. You may even decide to join the conversation. From faraway lands to your own backyard, with a small dash of pixie dust. Turn out the lights and open your minds. The journey is about to begin. Hey everybody, how's everybody doing? You guys have a great weekend, I hope. It's a great weekend to start summer. Lots of barbecues going on and things like that. Welcome. My name is Charlotte. I'm going to be your host for the next hour. I'm also the owner of the California Haunts Paranormal Investigation Team, based out of Sacramento, California. We are 45 strong up and down the state of California, which means if you have a paranormal need, we can get to you. We may not be able to get to you right away, but we can do that because the reason being, California is a big state, and so it might take us a while. But what we have for you instead is we have 5 mediums on staff who could call you and consult with you about what's going on. And in most cases, they can calm things down before we're able to get out there, which is really good, right? So yeah, you can find us on Facebook, you can find us on Twitter, you can find us on TikTok, you can find us at YouTube, you can find us on Twitch, you can find us on Instagram. And how do you do that? Well, Facebook, we are California Haunts. Instagram, we're Ghosty Gal, and that's all lowercase. Twitter, we are Cal Haunts. Twitch, we are Cal Haunts. And TikTok, we are California Haunts. So it's that easy. All right. If you're watching, and speaking of which, if you're watching from any of those today, especially Facebook, and you like what you see, please be sure to give me a thumbs up, give me a smiley face, give me a heart, because what that does is that puts us into the algorithm of Facebook. There's algorithms at Facebook and YouTube and TikTok, which when you get those smiley faces, it puts you up further so that a lot of people can see you. So essentially, every time we get one of those, it puts us into a better position for people outside of our audience here to see us. So if you'd like to do that, that'd be great. And also, if you like what you hear today and see today, you can also, if you haven't done so already, hit that follow button. I'd really appreciate it over at Facebook. And the same goes for YouTube. If you like what you hear today, please subscribe. We have 621 videos sitting over at YouTube, and they're all different topics. They're not only paranormal themed topics. They're like tonight's topic, or like the opioid pain thing we did the other night. I like to vary the topics of the shows because I'm a journalist, and that's what I like to do. I don't like to do the same topic all the time. So you can check that out. I've also taken the liberty of moving things around because, like I said, there's over 600 videos over there, and it's kind of confusing when you go in on the main page because they're all like bunched together. So what I've done is I've put them into categories so you can find stuff easier. For instance, if you like listening to the shows with Medium Nancy Matz on Fridays, she has her own file or folder that you can find. Or if you're into UFOs and contactees, there's a file for that as well. So there's all kinds of stuff in there. There's cryptid files, so it makes it easier for you to find the different shows you want to see. Okay, that being said, tonight we're doing something. We're going to talk about something that I'm really interested in. I can remember, I'm a backyard astronomer. I have always had a telescope. My dad, always either had binoculars when I was real tiny as a kid, and then we expanded to a 4-inch telescope, and then that went to an 8-inch telescope, and then I ended up with a 12-inch telescope. And I used to sit out back, and I even had a camera on my 12-inch, so I would make my attempt at taking photos of Jupiter and all the different planets and stuff. And I'm really excited to have this gentleman on, Professor Stephen Kane. And he's going to be talking about exoplanets and other celestial bodies. So it should be an interesting night. So without further ado, let me bring him in. Good evening, sir.
Hello, Charlotte. How are you doing? Oh, sorry, my chair just went back right at the right moment. That was perfect. I don't think that was paranormal.
I don't either. You never know.
Anyway, yes, thanks. Happy to be chatting with you.
Tell me about you, sir.
Oh, well, so I'm a professor at University of California. I recently crossed a boundary where I've lived longer in the United States than outside the United States. As you can probably tell from my accent, I'm not native. I grew up in outback Australia, and where I lived, I had access to spectacular night skies. I used to lie out on my trampoline during the 80s and just stare up at the night sky and, ask a whole bunch of questions about what could be out there. So that's what really inspired me to go on this journey. And it just so happened that when I started grad school in the mid 90s, that's when we started to find planets around other stars. Up until then, I'd just been obsessed with the solar system, completely obsessed, and still am. I mean, that's what I study now as well. But I mean, this opportunity to just look at an infinite number of planets and think about those, it's been a wild ride, shall we say. I mean, the last couple of decades, when you think about it, I said mid 90s, we're approaching the mid 2020s, so that's almost 30 years. And these past 30 years, what we've accomplished as a civilization, it's pretty extraordinary when you think about it.
It is. And when you talk about like growing up in the outback and laying down and looking at the stars, I can understand that. I didn't grow up like in the woods or anything or in the mountains, but I did. I grew up in like suburbia. So when I would look up, I would see the main stars. Where I could say, "Oh yeah, there's Orion." There's Orion because I could pick out the main stars, the Big Dipper. But when I would go up to the mountains, I was totally confused. I would look up and I thought, "Wow, I can't tell where anything's at. It's not where I'm used to it."
There's an old story about from back in the 90s that there was a power outage in LA County, and all of a sudden people could see the night sky in a way they couldn't before, and it precipitated an unprecedented amount of calls to 911 because people were freaked out. What is all of that stuff? So
I've been in areas probably like your outback. I've been in areas where it looks like you could actually reach up and touch the stars.
Yeah, well,
that low,
I still go to the southern hemisphere pretty regularly. I mean, of course, I go back to Australia from time to time, and occasionally I will take an American colleague with me who has never been to the southern hemisphere before. And the southern hemisphere points more directly at the galactic center, so there's a much better view there of the Milky Way. And so if you go there during the northern hemisphere summer, which is when the Earth has the best view of the galactic center, it could really freak people out. Like when I say I'd take American colleagues with me, I mean astronomers, right? So you'd think they would be used to this, but no, it can be quite an awe-inspiring thing if you haven't seen that before.
Oh, it's breathtaking, absolutely breathtathtaking. And like I said, you look up because you're used to, like me living where I live, and I'm so used because I can find the Pleiades, I can find, I can find the occasional galaxy and stuff with my telescope because I have one of those telescopes that has the electronics on there, so I just got to punch the little numbers in. But still, I could still find stuff. But when I get up in the mountains, it just amazes me. It's like being in a snow globe. That's what it reminds me of, being in a giant snow globe.
Yeah, and it's I find it a really great moment to just kind of have big picture thoughts, our place in the universe and how we really are. Carl Sagan, of course, spoke a lot about this pale blue dot that we live on, and this island of habitability, which is what I think a lot about. So yeah, it's good to think about those things from time to time.
Now, what is the difference between an exoplanet and a planet?
Well, so an exoplanet is a short hand way of saying extrasolar planet.
Okay.
And so it's just kind of a nickname that has evolved through time. But extrasolar is referring to outside of our solar system in the same way as we would say extraterrestrial means not from Earth. So that's what an exoplanet is, just a planet orbiting another star.
Okay. Yeah. Now, I grew up with books. I'm not going to say how old I am. I'm old enough. I grew up with the old encyclopedias. I remember around, because I liked to devour books when I was a kid and read, especially about astronomy, and the planets and all this. And I grew up at a time when the encyclopedias would say, man will go to the moon. That tells you, what it was like for me. That was the tail end. Before they switched the encyclopedias over, it was real close to that time,
Yeah, so for me, it sounds like it was the same for you, which is that the internet for me was my family's collection of we had the World Book Encyclopedia, those Encyclopedia Britannica, whichever set you
Right,
had.
right,
And
right.
so I would just read a lot of those. But more so, I would go to my grandmother's house, and she had some really old science books. And that's where it would show the size of Pluto as being bigger than the Earth. It's
Mhm.
and a lot of really interesting stuff. Because as you may know, one of the things that I study a lot is Venus,
Mhm.
and Venus is really interesting because we didn't understand what the surface of Venus was like until we went there. But prior to that, we thought there were animals living there. And so you look at these science books from back in the 50s and the
Yeah.
60s, and they're just incredibly speculative as to what life on our neighboring planet could be like.
Mhm. Mhm.
It's such a fun time of human imagination, you know.
Right.
So,
Right. It's amazing how much has changed. Like even the number of planets that we have now. That's all changed from what I grew up knowing.
yeah, I was talking to my students about that recently. I mean, of course, I talk a lot about how many exoplanets we've found, which is now
Mhm.
more than 5,000. Which,
Wow.
like I said, only 3 decades worth of work. It's pretty incredible. But of course, a big event was the whole change in classification of Pluto,
Mhm.
and so that certainly has changed during our lifetimes, and that's really interesting. Not so much from a scientific point of view, I think, because
Right.
Pluto doesn't care what we call it, but from a cultural point of view, it's incredibly fascinating because Pluto was the only planet that had been discovered by an American.
Mhm.
And so it's really interesting how ingrained Pluto became as a cultural phenomenon in the United States, and therefore the backlash that happened when we changed our mind about what to call it. So
I find it sad about Saturn now too. The news about Saturn and the rings right now, because I mean, there's nothing more beautiful to look at through a telescope or fascinating than Saturn. To see that with the rings around it. What as I said, as a professor scientist, what do you think is causing this thing to happen to the rings?
oh well, so you might need to be specific. There's a
Oh,
lot
I'm
of things
sorry. Okay,
happening
okay, I'm sorry.
with the rings. But are you talking about the degradation of the
Yes, the
rings?
degradation of the rings. I
Yeah.
should have been more specific. Sorry. Yes.
Yeah. Oh no. It's fine. I look at a lot of news stories and a lot of publications from my colleagues, and Saturn, of course, and the rings are
Hmm.
very intensely studied. Um, the rings have a lot of dynamics, and there's always interesting stuff coming about them. But the rings of Saturn, it's interesting because there's still a lot of shall we say, disagreement about how old the rings of Saturn are. Some of them, some people claim that the rings of Saturn are actually as old as the solar system, like 4.5 billion years. I find that unlikely, and
Hmm.
that's just because of what you're talking about, which is that the rings like that, they don't last forever. That's because as sparsely populated as they are, they do collide. The material collides with each other and kind of grinds itself down to
Right.
dust.
Right.
Plus, it gets collected onto the moons that are there,
Hmm.
and so they do disappear with time. Um, but there's hope because if the rings of Saturn are relatively young, then
Hmm.
that means there's plenty of opportunity to form new ones. And in fact, there's a lot of the speculation is about what is fueling the rings. So there's cometary impacts. There's the moons themselves, which can be crushed by the gravity of Saturn and
Hmm.
form new rings. I
Hmm.
mean, Uranus also has rings,
Right.
which is very very interesting, and I study those rings a lot as well. And one thing I recently published about is if Jupiter is more massive than all of the other planets combined, how
Hmm.
come it doesn't have rings?
Right. Right.
And so there's some good reasons for that, because Jupiter gets hit all the time by
Hmm.
objects. We saw that. I don't know if you remember back in, I think it was 1994, when there was a
Yes.
comet called Shoemaker-Levy hit And the Hubble Space Telescope had not long been up at the time, and so it pointed at Jupiter. Everything pointed at Jupiter, and we learned a lot. But all this to say is that Jupiter's been hit. It produces new rings, but around Jupiter they don't last very long, and that's because it has the Galilean moons, which kind of sweep all of that up. Saturn, as you're probably getting from what I'm saying, I'm not too sad about it. For one thing, I think this is kind of circle of life stuff, but also because I think there'll be more rings. We're looking at Saturn at a particular time in its history when its rings are on the decline, which means that there was a time in the past when the rings of Saturn, and this is hard to imagine, would have been even better. And I think that time will come again.
That's true, and I think we're at a point in time too where in our lifetime we're probably not going to see it anyway. So we just enjoy what we have,
Yeah.
It's the next generations down the line, the Picards, right? They're the ones that are going to see all that stuff.
Yeah, they'll be actually go there in person and
see,
take samples,
slingshot around Saturn, right? The other thing I was going to bring up is I remember how funny it was in the old science books as well, and I remember one of the certain things that stick in your head as a kid, and I remember when they were talking about Saturn and how gaseous it is and how, well, if you took Saturn and put it in the middle of the Atlantic Ocean, it would float.
Yes.
And I remember as a kid sitting there thinking, that would be really cool.
Yeah, well, I think, sometimes when I talk about that, this is, of course, a reference to the density of Saturn because the density is less than 1 gram per cubic centimeter, which is the density of water. Therefore, it would float. So I would love to see the bathtub in which we could conduct that experiment. We certainly wouldn't want to do it on Earth. Like if, as you suggested, we put Saturn in the Atlantic Ocean, we'd all be dead. We'd all be dead. It wouldn't be so much as putting Saturn in the Atlantic Ocean as putting the Atlantic Ocean on Saturn.
Right? That'd be pretty funny. So what do you think, as you look at the universe from your perspective, because I know I've always followed Carl Sagan, I followed Jack Horkheimer, because the PBS thing, the Keep Looking Up thing I would see. What changes have you seen, because we're talking about like Saturn's rings right now, and the exoplanets. What changes have you seen on all the planets in our solar system as opposed now as opposed to what it was before?
Right. Yeah. It's the example I gave earlier. I mean, that was about Venus and about how during the early '60s, in particular, there were a lot of people speculating and by the way, part of the reason that was the case for Venus is because it has this thick layer of clouds. So it just made people's imagination go nuts. That was not the case with Mars. Mars, where it was speculated that there could be life on the surface, not just life, but intelligent life, because of the canals that Percival Lowell thought he saw in the late 19th century. We very quickly figured out that was not caused by an intelligent civilization because we could see the surface of Mars through telescopes. It's got a very thin atmosphere. We could just see it. Venus, we couldn't see it, and so we had to actually go there and find out. But until we went there, we weren't really sure. And so there's a lot of things like that I've seen through my lifetime where it's these deep mysteries that we don't know unless we actually conduct the experiment that I think have been really, really cool. And so things like looking for evidence of past water on Mars, I think that continues to be a mystifying thing, which is pretty amazing. And as I mentioned, I study Venus a lot.
Sure.
And one of the recent discoveries we had for Venus is that it's still volcanically active, which we also weren't sure about. So, and that's important because it means if it's volcanically active, it's geologically active, which means that there's all kinds of interesting geology at the surface going on, which relates to whether it could have in the past been habitable like Earth and had liquid water oceans. I think a lot of the big discoveries have been from outside of our solar system, finding 5,000 planets. And as that relates to our solar system, what that has really done is it's answered this fundamental question: is our solar system normal or not?
Mm-hmm.
Because our solar system has 4 rocky planets close in and 4 giant planets further out,
Mm-hmm.
and because that's all we knew, we thought maybe that's normal, and it's not. It's not normal. Our solar system is really, really weird, and that to me is a fundamental thing to figure out why that's the case. Because especially when it comes to talking about life, because when we talk about life has evolved on Earth and what are the reasons behind that, and it's
Mm-hmm.
very easy to be anthropic about that and say, well, here are all the unique features of Earth, right? So Earth is a certain distance from the sun. It has a large moon. And there are many things that you can look at, like the Earth's magnetic field even, and say, is that important? But even beyond the Earth, we can look at things like we have a giant planet called Jupiter, which, as we were discussing earlier, gets hit occasionally. And when Jupiter gets hit, it could mean that it rescued Earth from being hit. So it kind of, it was like this absorber of a potential impactor that may have caused an extinction event. Didn't help the poor dinosaurs 65 million years ago, unfortunately. Jupiter was sleeping on the job, I guess. But I mean, is having a Jupiter-sized planet important? And if it is, then finding these planetary systems around other stars kind of tells us a lot about that, because we're finding that Jupiter-like planets are pretty rare. I think that's one of the most amazing things to me, is just realizing how unusual our planetary system is and what that could mean for the development of life.
Absolutely fascinating. How does one find an exoplanet?
With great difficulty. So more seriously, the way I put it is that this is a classic case of technology having to catch up to ideas, because this idea that other stars have planets is, of course, not new. In fact, the idea of other stars having planets actually goes back thousands of years. Like the Greeks were very prolific in talking about this. Epicurus, for one, was a Greek philosopher who spoke about the plurality of worlds and that they probably have life just like Earth. There were periods of human history, particularly during the Middle Ages, say 13th, 14th, 15th century, where saying things like that could get you in a lot of trouble. And so there was a period there when that kind of those kind of ideas were squashed. But then after that, in the last couple of hundred years, people were thinking about this a lot, as well as how could we actually do this? How could we verify it? And the 20th century in particular, early 20th century, people started to develop telescopes far better than they had been able to before. And they thought maybe they could, maybe they can't see the planet itself, because that's really hard, trying to see a faint object next to a very bright object, meaning its star. But maybe they can infer its existence indirectly by observing the effect the planet has on the star. In other words, the gravitational effect of the planet would make the star wobble. And so there are a lot of attempts to do that, and some claims of planet discoveries back in the 30s and the 40s. But these are very difficult observations to do, especially from the ground, when you're looking through the Earth's atmosphere. And if you're trying to detect the very tiny movement of a star, looking through the atmosphere, which makes the star move all over the place, which is what makes stars twinkle from the ground, then that's a real problem. And so these initial claims were refuted, because the way science works, other people try and go do this, they couldn't see the same thing, and it was traced down to the observations or the telescope itself. And so there was so many of these false alarms that by the time the 1980s came around, people just didn't take the search for planets around other stars seriously. It's hard to imagine that now, but during the 80s, if you went to a funding agency like NASA, it's kind of like that scene from Contact near the beginning, where Ellie, played by Jodie Foster, is going to all of these places to get private funding to continue her SETI work. and they just laugh her out.
Mhm.
It wasn't until finally somebody took a chance on her, which is part of that narrative. But that's what it was like to say, I'm going to look for planets around other stars during the 1980s. But then, as I mentioned earlier, during the 1990s, everything changed. That's when I got involved. I make it sound like those two things are connected. I came in and saved it. No, it wasn't like that. I came in because of the hard work of others before me who had enabled this, who had essentially developed the technology to actually be able to measure the motion of stars due to the gravitational effect, using technology that was just unbelievable.
Mhm.
And so that's the way that many of the hundreds of planets have been found using that method, the gravitational method. The vast majority of the more than 5,000 planets found so far have been actually found using the transit method, which is also an indirect technique. And the way that works is that you observe the planet pass between you and the star, and it blocks some of the light as it crosses the
That
star.
makes sense.
And so if you're able to measure the brightness of the star, so we're not measuring the movement, now the brightness, then you detect or you infer the presence of the planet. And not only that, because the bigger the planet, the more light it blocks, that
Mhm.
means that you get a measurement of how big the planet is. And that was what enabled NASA's Kepler mission to work, which was launched in 2009 and discovered on its own several thousand planets. And that mission was our first deep dive into finding planets the size of Earth. And so that's when I started to get involved in thinking about planetary habitability, because when we started finding planets the size of Earth, I realized that that meant that we were also finding planets the size of Venus because they're the same size.
Mhm.
How would we tell the difference between a habitable planet and an uninhabitable planet?
Mhm. Mhm.
Uh, and so that's what I spend a lot of my time thinking about now. But it's to answer your question. I mean, most of the planets have still been found using these indirect techniques.
Mhm.
Hopefully, within the next couple of decades, we will start to be able to directly image
Sure.
Earth-sized planets around other stars, which will be fantastic, of course.
Well, that's something people don't realize when you talk about the Earth's atmosphere is how really unstable it is. Now, people that have telescopes like I do, we get it. I mean, you're sitting there watching something and it's bouncing around. It's hard to keep a track on stuff unless you have a telescope that can track that stuff, which I do at this point. But
Yeah,
it's really hard. And then the other thing people don't realize is the first thing you learn as a backyard astronomer is when you're looking up, even with binoculars, there's a difference between what a star and a planet looks like when you're looking up. You can tell the difference because a star is always a pinpoint of light, no matter how you look at it, and a planet's always going to be round. But
yeah,
it's just that you have to train your eye to look for that stuff. And I can't imagine how difficult it would be with the telescopes. I mean, you guys deal with some real nice telescopes like Palomar and all those places. But I can't imagine how difficult it would be to have to look, like you say, behind the stars and around the stars to find these more fainter planets.
yeah. It's a really hard problem to solve, and you're absolutely right about the effect of the atmosphere. I mean, that's the analogy that's always made, is that if it's same as looking at an object at the bottom of the pool, and it kind of just goes all out because of the turbulence of the water.
Right.
For the big telescopes like Palomar and like Keck, we do use something called adaptive optics, which essentially shoots a laser into the atmosphere. I mean, it's a really incredible technology that we're able to shoot a laser into the sky and then use that to monitor the turbulence in the Earth's atmosphere in real time and
Mhm.
correct for it. So that does a pretty good job. But of course, there's no substitute for going to space, which is
Right.
with the NASA Kepler mission, to be able to measure the brightness of these stars to discover Earth-sized planets. It really needed very, very stable conditions, which we're just not able to do from the ground. But yeah, you're right. A lot of people don't realize what we can and cannot do from the ground.
Right.
And one thing I say to I gave a talk a couple of weeks ago where I asked people to raise their hands if they have seen Venus in the night sky, and only about a quarter of the people raised their hands. And I said, to those of you who didn't raise your hands, I have very good news for you. You're wrong. Because, I mean, Venus is the third brightest object in the sky. There's absolutely, if you're listening to this, there's absolutely no way you have not seen it. You've seen it. You just maybe didn't know what you're looking at. It's very, and by the way, it's very high in the sky at the moment. It's 7 p.m. in California now, like about an hour from now. If people go outside and look west, they'll see this bright star above the horizon, except it's not a star, it's our twin planet. And, I'm sure you've been doing this for many years, and you just kind of, you look for the objects that aren't twinkling, but also you learn where the ecliptic is, the plane of the solar system, and you just kind of look along there. And
and guys, also there's a lot of cool software out there that you can download for your cell phone that's free.
Oh, cheating.
You can cheat. It shows you what's over your head, and you're like, oh yeah,
It's so funny. Yeah, like my grad students, when we'll be outside and we'll be doing some stargazing, and they'll pull their phone out and they'll have their they'll have their app out, like, oh yeah, that's that.
Yeah.
And after having spent my teenage years memorizing star maps, I'm just shaking my head at these.
I agree with that.
Gen Z.
I admitted I have one on my phone, but I don't use it all the time. I do sometimes. Depends which telescope.
I use it too. I use it
because there's one thing I can't stand, and like I have an older Meade telescope that's a 4-inch, and trying to aim that sucker and get that sucker right where it needs to be, with that viewfinder is a pain in the butt. So sometimes that goes into play with that software. But as you can tell, I'm excited about this. I love this stuff. I can understand too where, in order to track these things better, these exoplanets, you would have to need something that's outside of the Earth's atmosphere, like Hubble or something to stare at. Was Hubble able to locate anything like that, or was it just taking pictures of the nebulas and all that?
Yeah, one of the interesting things in astronomy, when you look at the profile of a mission like Hubble, the thing to realize is that by the time a mission is launched, it's already been decades in the making, especially a flagship mission like Hubble and like James Webb. So James Webb, they essentially started planning that before even Hubble was launched, right? So that's been a long time. And so when people start planning these missions, they have particular science goals in mind, like they want to answer this question or that question about the universe. And so science doesn't stay still, and it changes. And so James Webb evolved a lot during the discovery of exoplanets in order to be useful for that. Now Hubble preceded all of that. When Hubble was launched, we didn't know of any planets around other stars, or at least hadn't been confirmed around any planets. Any stars like the sun. That came in the mid-90s. And so Hubble was really designed to do very faint, deep sky kind of work. And that means galaxies, extragalactic, cosmology, and it did some fantastic work on that. Some of the earliest famous images from Hubble are called the Hubble Deep Field. And if you're not familiar with that, you should, for your listeners, they should check it out. There's the Hubble Deep Field, and then later on, they did what I believe it's called the Ultra Deep Field. And essentially that means just taking Hubble and staring at a patch of sky that otherwise just looks like black space. But then you do this long exposure with Hubble, and it turns out it's full of galaxies, which is incredible. But so that's what it was designed for. So now when exoplanets came along, and particularly when we started discovering planets using the transit method, which is just measuring the brightness, then Hubble became a really useful resource for following up on these planet discoveries. Because it was designed for these deep, narrow field kind of work, it wasn't really designed to do wide field surveys. And so Hubble has never really been used to discover planets, but it
Mhm.
has been extremely valuable in doing follow-up work on planets we have discovered to to get better measurements of the transit, so we can get a better estimate of the radius of the planet, and even to do some atmospheric work as the planet passes between us and the star, and as the light passes through the atmosphere on its way to us, we see absorption features. And it's that's been the case with a lot of these missions, that
Mhm.
uh, that we've kind of had to shoehorn in the science
Right.
after their launch, just because the science has changed so much.
That was my next question now, because over the years, like growing up, with all those books, there was speculation about what Venus is made out of, what Saturn is, and all this. Now, in the case of these deep sky exoplanets, how are you guys able to come up with a conjecture of what their atmosphere and stuff's like?
Yeah, that's kind of the era in which we now find ourselves, due largely to the James Webb Space Telescope.
Mhm.
Um, and we've been waiting for this for a long time. And what I mean by that is, in the early 2000s, soon after we started discovering planets using the transit method, it was very quickly realized that there's a lot of different ways in which we can exploit the data from a transiting planet.
Mhm.
And one of the most important ways is the way I just mentioned, which is that as the planet is crossing the disk of the star, the light from the star passes through the essentially the limb of the planet, which is the very thin atmosphere, on its way to us, and then you get absorption of light at certain wavelengths.
Mhm.
And and that's really, really hard to do. That's another one of these things where if you try and do that from the ground, then it's a huge problem, but for a different reason than we mentioned before. Because when we were talking about trying to do ground-based observing before, we were talking about the effect of the turbulence of the Earth's atmosphere.
Right.
The other problem of the Earth's atmosphere is that it absorbs certain wavelengths. We call these atmospheric windows, and this is particularly true in the infrared,
Mhm.
in infrared and the ultraviolet. And of course, this is something we can all be very thankful for, because the absorbing effect of, say, ozone for ultraviolet is, if it wasn't for that, I mean, this was what happened during the 80s with the hole in the ozone layer in the southern hemisphere, and the poor old Aussies, got the brunt of that, because we saw a rise in skin cancer rates, um, and so we had to fix that. So these parts of wavelength space where the Earth's atmosphere is opaque is for our benefit. We have evolved to into that kind of space. But if you're trying to be an astronomer and observe at those wavelengths, it's a
Mhm.
problem, because it means that you're blind at some wavelengths, because the Earth's atmosphere is absorbing it all. And this is particularly true when we're trying to measure uh, the atmospheres of planets around other stars, because we get our most useful information often at near infrared and infrared wavelengths that are just
Mhm.
completely absorbed, or largely absorbed, by the Earth's atmosphere. And so we did some early work with another important telescope called the Spitzer Space Telescope, which is
Mhm.
kind of like the Hubble. Far few people know about Spitzer,
Mhm.
and I think there's a number of reasons for that. Hubble, because it observes in the optical, it's able to produce these glorious images, which the public love for very good reason. Spitzer observes mostly in the infrared, and so the pictures are, in my opinion, equally beautiful, but far less easy to explain to the public.
Mhm.
And plus, it didn't orbit the Earth. The Spitzer Space Telescope was in what's called an Earth trailing orbit. It followed the Earth around the sun, and that's because it's an infrared space telescope. You don't want this giant radiator, which is the Earth,
Right.
messing up your observation. So you had to have it far away. And so we. This is another case where Spitzer was planned decades before. There weren't even any exoplanets, but it just so happened Spitzer was launched right after we started discovering planets using the transit method, and we thought, oh my God, we can point Spitzer at these planets when they transit and start to measure their atmospheres. Now, because it wasn't designed for that, we did the best we could, and we got some interesting measurements. But what we really wanted to do is we want to do this work of how do you tell the difference between Earth and Venus, like terrestrial planets, things that were discovered by Kepler. And that really required James Webb. And so that's what we're doing now. A lot of the time that's spent, because it's hard to believe, but Webb has been up for 18 months now. I believe it was in Christmas. I think it was launched Christmas morning of 2021, and then it was made its way safely to the Lagrange point, where it's about 1 million miles from the Earth, further from the sun, and so it's been observing for well over a year now, and a lot of that time has been spent on exoplanets and their atmospheres, and so it'll be interesting over the coming years to see what we get. We've already had some pretty interesting results, which I can talk about, but yeah, that's how we're doing it with James Webb.
Before we get to your results, because I do want to hear those, my next question is, how far is the nearest exoplanet from us? And how long would it take to get there by standard, satellite or whatever?
Yeah, it's funny you ask that, because that is, I would say that's the number one question I'm always asked by the media when we have the exoplanet discoveries, is how far away is it? And, especially if we're talking about a planet, like a rocky planet that's in the habitable zone. And the implication can be, or the subtext of the question can be, when can I pack my bags and go there? It's like, but I kind of pessimistically point out that at least at this part of human history, all stars are at infinity. So it doesn't matter whether it's like 5 light years away or 1,000 light years away. To all intents and purposes, to a civilization that hasn't made it beyond the Earth's moon, it's at infinity. Right? But to answer your question, the nearest exoplanet, we are now aware of what is by definition the nearest exoplanet and always will be, because it orbits the nearest star, which is Proxima Centauri, and that's 4.22 light years away. And that, it just so happens that planet, it's probably rocky. We're not sure. Proxima Centauri, as you may know, is a small M dwarf star, so much cooler than the sun, and it is in the habitable zone of Proxima Centauri, and so there's a lot to speculate about there, right? Like, but buyer beware, because we speculated a lot about life on the surface of Venus in the early 60s, and look how that turned out. So
I also think a lot of that comes from, with the press asking these questions like this, from what's been going on, from Voyager, from Viking, from Magellan. You know what I mean? I think that's where a lot of that's come from, because we literally touched down on Mars. That's what people are thinking. Hey, are we able now, with the technology that we have, to go farther and touch down on these exoplanets? And I know the technology is not there yet because they're so far away, obviously.
Yeah. And just piece of trivia, our first soft landing on the surface of another planet was in 1970, and that was one of the Venera landers that landed on Venus. And our first picture from the surface of another planet was in 1975. That was also a Venera lander, also on Venus. They were, before we sent Viking to Mars, the United States and Soviet Russia were obsessed with Venus. It was really interesting. They were dumping all kinds of stuff on there. It was pretty amazing.
All right, so let's talk about what you mentioned earlier. Tell me, what you guys have already discovered about these exoplanets.
Yeah, so it's just been the first year of results that have come out so far, but there's already been some pretty interesting things. One is that we have detected carbon dioxide on another planet. Now, caveat to that, that is a gas giant planet, so it's not a terrestrial planet. But that's important because it shows that we can quite, I was going to say easily, that I don't want to trivialize the observations, but
Right.
James Webb is an extremely powerful tool. But the signature of carbon dioxide was extremely obvious in those data, and so that's good that we can do that. When it comes to terrestrial planets, one of the most studied systems is the TRAPPIST-1 system.
Okay.
And you and some of your listeners may have heard about TRAPPIST-1 before. It's been known since about 2015, I think it was when it was discovered, and it's really captured the attention of a lot of people because it is a system of 7 terrestrial planets, 7 that we know of. There could be more that we haven't discovered yet, but there's at least 7 planets in that system, all terrestrial, 3 of which are within the Hubble zone. 3/4, depending on how you count the boundaries of the Hubble zone. But it's also a system in which the star is extremely small. It's so small that it's barely a star at all, and because it's about 80 times the mass of Jupiter, and the threshold for becoming a star is around about 70 to 80 Jupiter masses. That's where you reach the temperature in the core of 10 million degrees Kelvin, where you can start fusing hydrogen into helium. And so it's right at that boundary. If it was any less massive, it would not be a star. So it's this tiny, tiny star, and it's got this incredibly complex system of terrestrial planets. So that all 7 of these planets that we know of transit. And that means that they're really prime candidates for pointing James Webb at during a transit and see if we can measure absorption features from their atmospheres. Because also these small stars tend to live a long time because they burn their fuel very, very slowly. And so this particular star is about 7.5 billion years old. So it's about 3 billion years older than the sun. And so you can only imagine the speculation that's gone on with this system. With 3 terrestrial planets in the Hubble zone, an old star, you kind of have this imagination about ancient civilizations that have just been like hanging around there for but this is where the issues come in, because being such a small star, one of the problems with small stars is that they tend to be very active. And there's a lot of astrophysical reasons for that, which I won't go into, but basically it's to do with the magnetic fields of these stars and the way in which they produce energy near the surface. It results in them having a lot of flares. So our sun is going through a period of high solar activity and creating fantastic aurora and things like that. But these small stars have that going on constantly at much higher amplitude, and that can have the effect of blowing the atmosphere away. And we know that atmospheres being blown away from planets is a thing because we've seen that for Mars. Because there's a NASA spacecraft called MAVEN, which orbits Mars and monitors the loss of the Martian atmosphere. And we've observed during periods of high solar activity, just the atmosphere of Mars just disappearing off into space. Earth also loses its atmosphere, but it replenishes it from volcanic emission. So it's kind of like this net zero effect. But so for these planets orbiting TRAPPIST-1, they've been subjected to this high flare environment for 7.5 billion years. What is the effect of that? Well, we learned the answer to that recently, because the innermost planet, when it was observed during the first year of James Webb observations, we've discovered that it actually has no atmosphere at all. Nothing. It's like it's about the size of the Earth, but it has no atmosphere, and it's uncertain yet when it would have lost its atmosphere. and we're still going to produce the same kind of measurements for the other planets in that system. But the early results from the subsequent planets is not looking good. And so this is kind of disparaging result when it comes to planets around these small stars, because these small stars are some of the most common types of star in the universe. And so from an astrobiology point of view, and are you familiar with the Drake equation?
Yes.
Which tries to calculate the number of advanced civilizations.
Right.
And one of the parameters in there is the number of stars which are suitable for hosting a habitable planet. And overwhelmingly, the biggest contributor to that factor are these small stars, just because there's so many of them. And if it turns out that these small stars, they're just unsuitable for hosting habitable planets, so there's still more work to be done on this, because there's a number of factors that go into this. But if that were found to actually be the case, that would be a huge kick in the guts to the whole endeavor of astrobiology and the search for life. It could. Some people are already speculating that this is the reason for the Fermi paradox, like why we haven't or may not have encountered advanced civilizations, or at least that they're not, hanging out in Times Square, as Neil deGrasse Tyson says. If they did land there, would anybody notice?
Right.
But that could be a contributor, just that these small stars. So anyway, so that's one of the big results myself and others have been thinking about.
One of the questions I had for that, though, is like, we can't be the only planet that's inhabited. I mean, obviously. So when you guys, when the scientists are looking for stuff, are they measuring it according to life here on Earth? See, this is what my perplexing thing is, because these other societies may not have to survive like we have to survive. They would have a different air environment and everything.
Yeah, I've been talking to my colleagues a lot about this, because there's a whole resurgence of the field of searching for technosignatures. And as you may be aware, there's biosignatures, in which we're measuring the composition of an atmosphere and looking for signs of chemical disequilibrium, which might be evidence of biological activities, such as if you have molecular oxygen along with methane, which very quickly react with each other, and so the methane preferentially would be removed, and then you'd end up with carbon dioxide and water. But that's just like biology at the surface, which would be the case for the vast majority of Earth's history thus far. It doesn't require any advanced civilization that can broadcast across space. Well, some of my colleagues look for technosignatures. They're looking for megastructures or evidence of night lights on the night side of a planet. All kinds of interesting ideas. The big difference between these two efforts is that biosignatures, even biosignatures on its own, is extremely difficult, because, like you said, it's extremely difficult to separate yourself from an Earth-centric viewpoint, which is, this is how we know how life worked on Earth. And so this is what we're going to look for elsewhere, which is fine. But I mean, we shouldn't box ourselves in, and it's really hard not to. And there are people who try and look for all the possible chemical reactions, the full parameter space, much of which may not have ever happened on Earth. But they try and think about the other possibilities. Some people even say, we don't really know what we're looking for, but we'll know it when we see it. I'm not convinced that's true either. I think many times we'll see evidence for life, but we won't even really recognize it. But that's the case for biosignatures, where all you're trying to do is do a traceability matrix of all the possible chemical reactions and the biochemical reactions. Now, when it comes to technosignatures, on top of all that, you're overlaying things like cultural motivations and all of the stochasticism of those kinds of pathways that go well beyond our current culture. And I think that's many times more difficult to predict what the motivational and cultural reasons would be for an advanced civilization to do whatever it's doing. Now, a lot of the stuff that's been written about this has been within the context of energy consumption, which is the premise behind the Kardashev scale. A type 1 civilization utilizes all the energy from the planet. A type 2 uses all the I think maybe type 1 uses all the energy from the planet. Type 2 uses all from the star. Type 3 can use all the energy from its galaxy. But it's this requirement of energy in order to sustain whatever it is, like whether it be the biology, whether it be the society, all of these things require energy. And so provided that, in the same way, when we talk about life, there tends to be a mantra of follow the water,
right?
Which, we can discuss about whether that's the right approach either, because once again, that's Earth-centric way of looking at it.
Right.
But when it comes to advanced civilizations, there can be a premise of follow the energy. Which may be okay, but it's still extremely broad. And yeah, I think it's a really, really difficult problem to solve.
Well, even here on Earth, let's think about that through the history of the Earth. There's us that live in the cities, and there's the people like the Navajo and the people, the Aborigines that live out in the outback and the desert. And they survive just fine on however they're doing it. If we from the city went out there to do that, just all of a sudden all our stuff was taken away, there'd be a lot of people that weren't so good. You know what I mean? So I think that's part of it, because with these other outlying planets, they're surviving based on whatever their environment is.
Right. Yeah. That's true. That one of the tenets, of course, of natural selection is adaptation to the environment.
Yep.
It has to adapt to because that's what you're given. You got to find that pathway within that environment. It's just trying to understand what are the boundaries. So provided that the boundaries of your environment don't move too far to the left or too far to the right, you can get away with that, even if it's in an extremophile sense. But it's really hard to know what the boundaries are,
right?
And depending on the biological pathways,
right?
I mean, there's you can start with, and sometimes my conversation with my colleagues goes this way because you can get disagreement on so many of these issues, so then you'll start, okay, where can we agree that life couldn't exist? All right, let's start with the surface of the sun, right? or something like that. Like, let's just get somewhere we agree, and then talk from there. But it's interesting how quickly you can find things or pathways that other people may not have thought of.
So what's next for you?
As I mentioned, what I tend to do is I'm thinking about what are the processes that result in a planet turning out like Earth. That is the long-term sustainability of temperatures that allow for surface liquid water oceans where you can have biochemistry occur. And I look at Venus as a counterpoint to that. Okay, so that's a case where it went wrong. And I look at all the various factors for a planet, meaning the size, the mass, the distance from the star, meaning the energy received at the top of the atmosphere, the magnetic field, whether it has a moon, and other things that I mentioned, like the effect of other planets in the system. You can literally list out hundreds of things that can influence the evolution of a planet through time. Then the challenge is to rank those. Which is the most important to which is the least important, because you can think of something like the tilt of the Earth's axis,
right?
Is that and that's controlling the seasons. But like you said, there's still evolutionary pathways that would adapt to those different seasonal changes. And so is that an important effect, or is it more of a minor effect? And so, yeah, so what I've been working on is that, and in order to do that properly, I'm trying to learn more about Venus, because we know very little about Venus.
Right.
And if Venus was once like Earth, like it had surface liquid water oceans, and that's pretty profound, because it could mean that, say, 2 billion years ago, we had two planets that looked, well, really like twins.
Right.
And that might be good news in the search for life, in showing that having surface liquid water is maybe more common than we thought, but also a warning in the sense that if you have it, you can also lose it.
Right.
Right. Which is what the purpose of Venus might be, as a warning to all of us. And so I'm on the science team for some of the new NASA missions that are going back to Venus to try and solve some of these.
Fantastic. How can people find you, sir?
Well, they can find me on Twitter. I have a Twitter handle called Exocytherean. For those of you who know your mythology, you might recognize the word Cytherean. That's Cytherean. That means pertaining to the planet Venus. And so Exocytherean obviously is a reference to my search for other Venuses. And they can also find stephenkane.net is my main website where they can look me up.
All right. Thank you so much for coming on. This was fantastic.
Oh, it's my pleasure. It was a lot of fun.
Oh my gosh. I'd love to get you on again to talk more about this. This is crazy. I could go for hours on this subject.
Me too.
All right, sir. Well, thank you so much for being on, and it was a treat.
All right.
And
Thanks a lot.
I will definitely be in touch with you again. Okay?
All right. Great.
All right. Thank you, sir. Have a good one. My mouse. There we go. Wow, that was so much fun talking to him. And I hope you guys learned a lot, because I did too. I was absolutely fascinated. I could pick this man's brains for hours. It's just incredible. Tomorrow we're shifting gears a little bit, and we're going to be talking with Jeffrey Danilick about Atlantis. So there's some new information about Atlantis that's been coming out recently, and he happens to have it. So we're going to be discussing that with him tomorrow, and that'll be our usual time right now, 6:30 p.m. Pacific. All right. Okay. If you like the show, share it with 5 people. If you hated the show, share it with 5 of your enemies. We are equal opportunity here at California Haunts Radio, and we're just simply trying to get the word out about our little old show. So if you could do that, help me out a little bit, that'd be great. Again, if you're watching from Facebook and you like what you saw tonight, please be sure to hit that follow button. Give us some thumbs up, some smileys. That would be great. If you're watching from YouTube, you like what you hear tonight and saw, give me some smileys and some thumbs up and all that good stuff. And again, if you haven't subscribed, please do so already. I've got some contact information for him to show before I close this out tonight. But I want to thank everybody for coming, and I really, really appreciate it. Be sure to visit the YouTube page. Everything we've done for the last 3 years is sitting over there. And we're going to get the website back up and running as well. Had some technical difficulties with that. So that'll be this week sometime. And for the Patreon fans, it's finally happening. I keep saying it's happening. It's happening. The interview with Gina Rock, Tinkerbell, is going to be up on Patreon tomorrow. I'm going to have that up for you guys to see tomorrow. And it's a really, really cool interview with lots of photos of her. And it covers all her life. So I think you're going to find that interesting. She's a fascinating lady to talk to. Anyway, I want to say good night, and I will see you guys tomorrow. So let me go ahead and give you his contact information, and we can go from there. Okay, the websites are astro.ucr.edu/members/faculty/Kane. Okay? And then you've got you got the other one that that flashed up too. It was too fast. He has a research paper out as well. Recheck this. It went too fast. I don't know. I think I set the settings too fast. But anyway, check that out and check out his website. And just like the website he mentioned, it's all there. Okay. Well, thank you very much, everybody. I will see you tomorrow, and have a good rest of your evening.